All right, today we're looking at values of the trigonometric ratios. We have two basic common triangles. One is the 30, 60, 90 degree triangle. And if you look in the figure here, we get the 30, 90, 60 degree triangle from an equilateral triangle. An equilateral triangle, all the sides are the same length, which means that all of the angles are the same length. So if we bisect this top angle, then we divide that angle into two angles with each being 30 degrees. And if we bisect that angle, we're going to come down and bisect this line. So instead of this whole bottom base of this triangle being S, it's going to be S over 2. So we have two triangles. Both are 30, 90, 60 degree. Okay. We can find the values of the angles. For example, of a 30 degree angle. Suppose we have this picture here where one leg is 1 leg is square root of 3, the hypotenuse being 2. Then we can find different trigonometric ratios. Like if we're looking at this 30 degree angle here, then sine, remember, is opposite over hypotenuse, so it's 1/2. Cosine is adjacent over hypotenuse, is square root of 3 over 2. Tangent is opposite, 1 over adjacent, 1 over the square root of 3. If you rationalize that, it's the same as square root of 3 over 3. If you remember from algebra, an expression is not simple. A radical expression is not simplified if there is a radical in the denominator. So if you have something like 1 over square root of 3, you can multiply both numerator and denominator by square root of 3. So the numerator, 1 times square root of 3 is square root of 3. But the square root of 3 times the square root of 3 is the square root of 3 squared, which is just 3. So throughout this process, you may get a ratio that's 1 over the square root of 3, but the book is going to rationalize that denominator. We also have the 45, 45, 90 degree triangle. Okay. Notice that since this is 45 degrees, this is 45 degrees, so opposite sides have to be equal. 1 and 1, and then this becomes the square root of 2 if that's the case by the Pythagorean theorem. So you can find the value of sine. Okay, opposite over hypotenuse, which is 1 over the square root of 2, but when you rationalize, you get square root of 2 over 2. And so you can find all the trigonometric values for these different angles here. Now, we can also find the trigonometric ratios by using a calculator. You may have something with a decimal, so you will need a calculator for this test. I am going to use in this lecture a calculator so that you can see one that I found on the internet. But when you're doing your test, you need to make sure you have a physical calculator. When you're doing your homework, you can use an online calculator. But during your test, if you bring up any web pages and try to access anything, it's going to knock you out of that test. So you do need to have a physical calculator with you. And it's best that you do your homework with the same calculator that you're going to be doing that test with, so you will know the different keystrokes. Some calculators require a different key sequence than others. So you need to get a calculator, do some of these problems, and learn how to work. You can go to the back of the book and look at some of the odd number exercises to make sure that you know the key sequence for your calculator. So just be aware, the calculator I'm going to use here, it may be a totally different key sequence. Okay? It may be a totally different key sequence. So let's look at what we have here. Another thing you need to make sure is that your calculator is in degree mode. Now in higher level math we use radian mode, but here for this class we're going to use degree mode. You're going to see sine, cosine, and tangent on your calculator, but you won't see cosecant, you won't see secant, and you won't see cotangent. But you need to remember that those are reciprocal functions. 1 over sine is cosecant, so if you're asked to find cosecant, you can do 1 over 1 over sine and find that value. Okay. Let's look at the calculator for a minute. Here, notice we have tangent, we have sine, cosine, and tangent there. Okay. Next to it, we have a cosine to the negative first power. This represents the inverse or arc cosine. And what happens is when you use that point or this button here, you end up getting an angle back. So we have the inverse of tangent, which is arctangent, the inverse of sine, which is arcsine. Now these other buttons down here represent something that you don't need to know with the sine h. That's the hyperbolic sine and in the inverse of hyperbolic sine, but you don't need to know those for this class. Again, make sure that you have your calculator in degree mode and not radian mode. So in exercise number 2 over here, it says to find sine of 21.0 degrees. Okay. Here they don't give us an approximation that we have to, or a particular value that we have to round to, but I think we're going to round to 4 decimal places. Okay. That's what we're going to do here. So what I do, and you need to know the key sequence for your calculator. I'm going to hit sine, and then I'm going to do 21.0, and I'm going to close that parentheses. The calculator we're using here, it has order of operations programmed in it. If you are using a basic scientific calculator that maybe is an older calculator, you may have to put in 21.0 and then hit the sine button. Okay? But here for this calculator, we put in sine and we do 21.0. And what we get back is 0.3584. Okay, so we're going out to 4 decimals, 0.358, round it up to 4. So you need to make sure that you know how to use your calculator. All right, the next problem is cotangent of 15.4. Remember that there is no cotangent button, but cotangent is 1 over tangent. So you need to do 1 over tangent of 15.4 degrees. Let's see what happens when we put that on our calculator. 1, we got to clear it out first. 1 divided by tangent 15.4. Close that parentheses, equals. Okay, so here we get 3.60. We're going to round at the 4th 5. 3.605. Again, you need to look at the key sequence of your calculator. You may have to do 1 divided by, open up a parentheses, and you may need to do the value and then tangent button. So I can't stress enough on how important it is for you to know how to work your calculator. We have cosecant. Remember, cosecant is 1 over sine. So we're doing 1 over sine of 56.1 degrees. And let's see what that gets us. Go back to our calculator, clear it out. 1 divided by sine of 56.1. Close parentheses, equals. All right, we have 1.2048. 1.2048. And then we look at cosine of 52.9 degrees. Let's clear it out. Hit cosine of 52. Let's clear that. We hit the wrong button. cosine of 52.9 degrees, close parentheses, equals. It is 0.6032. Okay. In the next exercises, they want us to use a calculator to determine the value of the angle to the nearest 0.1%, 1.1 degree. So this is where we're now going to have to use the inverse function. So tangent of alpha equals 0.2126. So what we need to do is we need to do tangent, inverse tangent of our 0.2126. And what comes out is going to be the angle alpha. Alpha equals this. So let's go back to our calculator. This is the inverse tangent button, tangent to the negative first power. And we're looking at inverse tangent of okay. Point 2.126 close parentheses equals. Okay. Notice what we get back, and remember you round to the tenths place. That's 12.0 degrees. 12.0 degrees. Okay, let's look at number 20. Alpha is going to be the inverse cosine of 0.7944. So let's look at our calculator. We're going to do inverse cosine of 0.7944. And what we get is 37.4 degrees. 37.4 degrees is what we get there. And let's look at number 28. Let's look at number 28. All right, we need to get this expression here in terms of one of our three basic trigonometric functions that we have on our calculator. Okay, remember that cosecant alpha is 1 over sine alpha. So if I cross multiply, I have sine alpha times this 2.608 equals 1. And in order for me to get sine alpha on one side by itself, let's go ahead and write all the steps out. 2.608 equals 1 times 1, which is 1. So that sine alpha is 1 over 2.608. So what this means now is that alpha is the inverse sine of 1 over 2.608. And you have to do this because our calculator, as you can see, we don't have the cosecant button. Okay? And the reciprocal of cosecant, the reciprocal of sine is not necessarily, you can't do 1 over the inverse of sine. Okay? But 1 over the inverse of sine we're doing here of our 1 divided by our 2.608 is going to equal 22.5 degrees. Alpha is 22.5 degrees. Okay, so now we're going to look at some different problems here. It says to use a calculator to and the given trigonometric ratio to find the indicated trigonometric ratio. So we have this picture here. We have that cosine of alpha is 0.8290, and they want us to find tangent of alpha. Well, the first thing we need to do is to find alpha. Alpha is going to be the inverse cosine of 0.8290. So we do inverse cosine of our 0.8290. So alpha is going to be 34 degrees. So now we can find tangent of 34 degrees. Okay. And again, let's go out 4 decimals, 0.6746. Okay, 0.6746. Let's look at another problem like this. Number 40. Actually, this is the figure here that we use for number 40. And the directions are a little bit different. The directions for number 40, they want us to find to the nearest 0.1 angle alpha in the picture. So they want us to find alpha, knowing that A is 3.2 and B is 2.0. They want us to find this angle of alpha. Well, we're given in relation to alpha opposite over adjacent, so we know that tangent alpha is opposite over adjacent. So that alpha is going to be the inverse tangent of this 3.2 over 2.0. Let's bring up our calculator and see what we get. We get inverse tangent of 3.2 over 2.0. 3.2 divided by 2.0. And with that, we get, if we round to the nearest degree, 58 degrees. Alpha is 58 degrees. Okay, so this was just a little lesson in showing you how to use your calculator in finding these measurements with the different trigonometric functions.